Remember, derivative of cofunctions are negative.
So okay.
Okay. My favorite problem is, what's the derivative of sine x? So, this is sort of an exercise in, do you understand the sort of the composition of functions, and how well do you say the word stuff? Right? So I'm going to try to color code. So when I look at this, I see sine of stuff. Does everybody see sine of stuff? And I know that the derivative of sine of stuff is cosine of stuff, right? We okay with that? So my stuff is, well, it's just this part, isn't it? It's sine of sine x, right? We okay with that?
Yeah.
All right, and so now my eyes focus just on the stuff. They're ignoring the green, right? Because the derivative of sine stuff is cosine stuff and the derivative of this, right? And so I'm only focusing on this purple thing, right? And so now when I look at this purple thing, I see sine of stuff. Well, I know how to take the derivative of sine of stuff. Right? There's my stuff, right? I know the derivative of sine of stuff is going to be cosine of stuff, right? But I said the word stuff, didn't I? And so now I have to take the derivative of the stuff. In this case, my stuff is sine x, and so that's going to give me cosine x. There's your answer. Notice there wasn't any algebra involved in this. This was an exercise of, when you look at this whole composition of functions, can you sort of isolate what you need to isolate? Like the first thing you look at, you don't see sine of sine x. No, right? You don't see sine of sine x. You don't see that. What you see is sine of stuff. And when you see sine of stuff, you say, well, I don't care about this, but I know it's going to be cosine stuff, right? And then when I write down the stuff, I only look at what I just wrote down, and my job is to take the derivative of this. And so now I ask, what is this? This is sine of stuff. The derivative of sine of stuff is cosine stuff. But I said the word stuff, so the derivative of the stuff was cosine x. The reason I like this problem is it's not very labor intensive, right? It's not like some of the ugly stuff that I made you do yesterday. But it's trying to train your eyes as what's important. Because not everything's important at the beginning of the problem. Just different parts are. All right. So what are we doing today? Well, today we have to talk about how do we do chain rule with charts information. And this is actually pretty relevant on the AP exam because they love to ask questions with product, quotient rule, and chain rule with charts. It's kind of funny is that if you were to actually take this course in college, they wouldn't care at all about using charts. But on the AP exam, they make a big deal about it. And since this is the AP course, my goal is to get you ready for the AP exam, I need to talk about charts. So, for you at home, if you look in OneNote, there's your homework for tomorrow. There's this file that I'm about to put up here. And let's see, I'm about to pull it up, so.
Is this the last thing we're learning before the quiz?
Yes. The quiz itself is just on chain rule.
Okay. So not this?
This is chain rule.
Oh, okay.
Yeah. But before I start this, let me scroll up to the top. All right. All right. So I need to give you the official. I've got to give you the official, the official notation of chain rule. So kind of the official notation of chain rule is you have to start with a composition of functions. So let's say I define h of x equal f of g of x. Okay? So like this function is a composition of other two functions, and this marker's dying. Whoops, that is nowhere close. So h prime of x is going to equal f prime of stuff times g prime of stuff. And can you see that's kind of the same thing we were doing with like trig functions? I had a function inside of another function, like with that sine of sine x. I had a sine inside a bigger sine function.
Yeah.
So this is f of g of x, right? That's my composition of function. So if I take the derivative of that, that's going to be f prime of stuff, but I said the word stuff, so I need to take the derivative of stuff, which is over here.
But then if it's really chain rule, you have to take the
Derivative of x, which is going to be 1.
Right.
Right? All right, so this is a big deal. In fact, I probably should have written it off to the side, so I am. Oh, I will. So now let's look at what I want to give you for homework, which is this thing. So what I'm going to we're going to walk through some things. All right. So it's kind of the same thing. It says, let h of x equal f of g of x. Oh, what's h prime of x, right? We've already done that, so go ahead and fill that part out. That's going to give me f prime of g of x times g prime of x. And I bet you can figure out what j prime of x is, right? If j of x is equal to g of f of x, right? Go ahead and write that part down. All right, so you should have written down. Actually, since I'm going to be scrolling, I'm going to put this over here. So h of x is going to equal f prime of g of x, g prime of x, and j prime of x is going to equal g prime of f of x times f prime of x. Okay. All right. So I'm not going to do all of these because you'll have to do some of these. But I do want to talk about, I'm going to do problem 1, and then I'll have you, I'll actually do problem 1 and problem 5, and then that's going to be the example of how to do the rest of this section. So first off, if it says compute h prime of 4, well, h prime of 4, so if this is h, this is f of g of 4. So this is effectively an algebra 2 question. The algebra 2 question is compute g of 4. Well, they give you a bunch of information. So, and this is pretty typical of, this is kind of the format that they would put on the AP exam. So g of 4, let's see, that's going to be -2. So this is going to be f of -2. And then I'll say, well, f of -2 is 4. Everybody see how that worked? Like our function notation from algebra 2? Okay. And I'm a little more interested in, well, what about h prime of 4? Well, as far as computing h prime of 4, what I should have done, scrolled up a little bit, yeah. So h prime of 4, well, h prime is this thing where this is going to be f prime of g of x times g prime of x. But they want h prime of 4, so that means this is a 4 and this is a 4. And now we look at our information. And when I go through this, like I see the g prime of 4, I look, okay, g prime of 4 is a 2. And g of 4 is a -2. Just plugging different values in. But now this means I need to compute, just erase this and put a -2 here. But now I need to compute f prime of negative 2. So here's f prime of negative 2, which gives me negative 4.
Times 2.
Times 2, and so this whole thing gives me negative 8. What the AP exam, this shows up, sometimes it shows up as a multiple choice question. Sometimes this will show up as in a free response question where they give you a bunch of information and you're expected to come up with it. I kind of like these because calculator didn't help you out one bit. I know there's lots of online calculator stuff that you can just type stuff in. Even your calculator computes derivatives of stuff. But there's no online calculator that can compute this with a chart. Right? But this is really testing how well do you understand chain rule. Right? Sort of at its core, it's like it cuts out all the ugly algebra. I mean, the extent of any computation is, can you multiply negative 4 times 2? Obviously, you use a calculator for that, but I really don't think anybody in here needs to do that part. All right? Did this make sense?
Yeah.
Did I mess up?
I don't know.
I messed up?
Do you multiply negative 4, negative 2?
No, negative 4. Oh, okay. All right. So let me write it. I was running out of room. I'll write it bigger over here so I can. Are we okay that h prime of x is equal to f prime of g of x times g prime of x? Are we okay with that part?
Yeah.
We're good with that? All right. And if I want h prime of 4, that means this is a 4, this is a 4, and this is a 4, right? And now we have to get our information from our lovely chart. G prime of 4. Well, there's G prime of 4 is a 2. Are we okay? G prime of 4 is a 2. So this whole thing is now a 2. Now, this is f prime of g of 4, so I need to compute what g of 4 is. And so g of 4 is negative 2. Are we okay with that part? So that means this is a negative 2. Are we okay with that part? Well, now I have to compute what's f prime of negative 2. And I have to compute, I have to find that information. And so here's f prime of negative 2, which is negative 4. And so this becomes a negative 4. And so I have negative 4 times 2, which gives me a negative 8, and that's how I got the answer. Did that make sense? Right. So this is like, these problems are how well do you understand composition of functions when you're taking derivatives, and this is really measuring how well do you understand like the whole chain rule part. So the first part, and you sort of keep in mind, this is not calculus because there's no derivative, you're just computing, so you wouldn't even use these derivative parts for questions 1 through 4, and questions 5 through 8. But I want to talk about question 9. This is a pretty common thing to ask given this information. So I want to make sure we can approach this. One of these is, I'll have to look at it, I think, tangent line. Yeah, well, this one's a harder question, so I want to talk about it, but I'm definitely going to talk about 9 and 12. So, how do you approach 9? Well, so it says, find the equation of the tangent line of f at x equals negative 2. So if x equals negative 2, how do we find an equation of a tangent line? Well, let me get my chart because I need my information. So to find an equation of a tangent line, I need a point and a slope, right? At x equals negative 2, let's see, this is telling me f of negative 2 is equal to 4. So I have the point negative 2 comma 4. There's my point. My slope, as I need to know what f prime of negative 2 is. And f prime of negative 2 is a negative 4. So that's my slope. Here's my slope, here's my point. Pretty much done, right? It's going to give us y minus 4 is equal to negative 4 times x plus 2. And there's our equation of our line. Everybody okay with that part?
Can you do that again?
Okay, are you okay that this is your point?
Yeah.
Are you okay with this is your slope?
Yeah.
So for the slope, we just plug the x value into the derivative of it.
Well, that's, what does the derivative represent?
It's the slope.
Slope of the tangent line.
Oh, okay.
Right? So this question, find an equation of a tangent line, is going to be asked frequently for the entire year. And anytime you're asked to find an equation of a tangent line, your job is, I need to identify, I got to find out what's my point, what's my slope.
And then you just write it.
And then you point slope form. Right? So like question 9 was kind of like the warm up. This is, question 9 has absolutely nothing to do with chain rule, because I could have asked this question last week. Because I told you, in this chart, I'm telling you, okay, here's the derivative, here's the y value, so given this information, you should be able to find an equation of a line at f at any of these values. All right, now, the chain rule question has to do with 10. All right, so question 10 is, now it's asking you to find the equation of the tangent line of h. Well, h they've defined as, h of x is defined as f of g of x. And we're interested at x is equal to negative 2. Well, you've actually already done the work. Had I done the work yet? Yeah, I think I have. No, I hadn't done the work. So if the chart was not continuous and differentiable, how would the questions change? Well, if it's not continuous and differentiable, you couldn't answer the question. Because if for this to say it's differentiable, that implies that derivatives exist. And so if they didn't say differentiable, then these values, you couldn't do any of the problems. Pretty much this whole idea of things being continuous and differentiable, anything that we do in calculus kind of particularly this semester, requires that things are continuous and differentiable. If it's not, then none of the rules that we've talked about ever work. All right, so back to problem 10. Problem 10 is find an equation of a tangent line to h of x at x equals negative 2. Well, I have to do the same thing. I need a point and I need a slope. So I need to compute what h of 2 is, which is, let's see, that's f of g of 2. And what's g of 2? G of 2 is negative 4. And so f of negative 4 is 2. F of negative 4 is 2. So what I now have is my point is going to be 2 comma, or negative 2 comma 2. Again, the algebra composition function question. So there's your point. How do you find the slope? Well, your slope has to do with computing h prime of x, which we've already computed as f prime of g of x times g prime of x. In this case, I need to plug in negative 2. So if I plug in a negative 2, a negative 2, and a negative 2, and I go look at my chart, let's see, g prime of negative 2 is negative 2. That just gives me a negative 2. G of negative 2 is 0. Actually, I should probably change colors. And so f prime of 0 is 2. And so I get 2 times negative 2. This whole thing's going to give me negative 4. So my slope is negative 4. So here's my point, here's my slope. And once I've got that information, then I can set it up as y minus 2 is equal to negative 4 times x plus 2. So this is applying our whole chain rule stuff. So as you're doing these, sort of keep in mind, if you don't have a derivative, it's an algebra 2 question. Like if you don't see the prime, it's an algebra 2 question. And like the first 8 problems are talking about just sort of computing values. Yes?
Why did you plug in negative 2 into the H equation? Or why did you plug in 2
It's
into the
supposed to be negative 4, you put in 2 instead, for the point.
Can I plug in 2?
Yeah, in the top equation, you plug in 2 instead of negative.
Aww. Booger. Yeah. So my algebra 2 skills are wrong. So if I plug in negative 2, let's see, what's h of, so what's g of negative 2? So g of negative 2 is 0. So this whole thing was 0, and then f of 0 was negative 4. So it should have been negative 2, 4. Negative 4.
Negative.
And there's the, so that's going to make, that would change that to a plus 4. So, yeah, sorry. I wrote negative 2 and then I, but at this point, there's not many applications I can have you do as far as derivatives go. In fact, the only application I've had you do with derivatives is find an equation of a tangent line. And that's what I'm having you do here. All right, I need to, let's see. So these are almost the same type of question. No. These are almost the same type of question, just one's with H and one's with J. This one's harder. I don't know if I even want to approach it. Actually, this one's not hard. These are harder. I want to talk about this one, and then I'm going to talk about 12 and 13. Because this could be a very common question on the AP exam, so I definitely want to talk about this. And I want to talk about 12 and 13, and we're going to see how this ends up being a significantly harder question than this one. All right? Because keep in mind, this is F. We're not dealing with composition of functions. H and J, the composition of functions, make it a little ugly. So 12. Where is it known that F has horizontal tangents? Well, for F to have a horizontal tangent, what has to happen? For a graph to have a horizontal tangent, what can you tell me about the derivative? The slope is 0, okay? We say horizontal tangent is your slope is 0. It's a flat spot. All right? So is there any place where F has a slope of 0?
4. Yeah, negative 4.
Negative 4. Like if we look along here, notice F prime equals 0, right? So F prime equals 0 at negative 4. Right? So that means, like, if you plug negative 4 in, you get a slope of 0. So where does F have a horizontal tangent? At x equals 4. We okay? That's kind of an easy question if you know what you're looking for.
Right.
Does everybody understand what you're looking for? Right? So that part's not so bad. All right? The next part is, the next part asks, well, where does H have a horizontal tangent? Okay?
But H is not known.
Well, so for that question, we were just interested in f prime of x. Where does f prime of x equal 0? Well, easy. Duh, there. That's the only place. Negative 4, x equals negative 4. We're done. Next question. Well, what about where h has a horizontal tangent? So we're interested in where h prime of x is equal to 0, right? So where does h prime of x equal 0? Well, let's see. H prime of x, well, that was f prime of g of x times g prime of x, I want to know where that equals 0. Well, anytime you have two things multiplied together equaling 0, I've got to look for two places. I've got to look for where does this equal 0, right? And where does this equal 0?
So where does g of prime equal 0?
Where does g prime of x equal 0? So that's not a hard question,
Negative 4.
right? And so g prime equals 0, also negative 4. So at x equals negative 4, we get negative 4 for that one. So that one's not so bad. But where it gets a little tricky is this part. See, I want to know where does f prime of g of x equal 0?
2.
Okay? Walk me through where you got that.
Oh, I just randomly plugged them in.
Oh, yeah, okay. You're like, okay, how do I make this 0, right?
Yeah.
Well, let's think about it. You don't have to randomly plug in. You can approach it. Here's how I approach it. Are we okay that f prime of negative 4 is 0?
Yes.
Are we okay with that? Because we want f prime of x to equal 0. We want f prime to be 0. And that happens when we plug a negative 4 in here. And so what I know is if this thing equals negative 4, right? Because I know that f prime of negative 4 is equal to 0. So I know if g of x equals negative 4, I get a 0. And so now I'm looking for, well, where does g of x equal negative 4?
Which is at 2.
Which is at 2. Oh, and so that's going to happen when x is equal to 2. So you didn't have to randomly guess. I don't know, did you go through that process in your head, or did you just start?
Yeah, I just randomly, it was like my first guess.
Oh, it was your first guess, so you said, okay, what happens if I get that part? And honestly, you could guess, because there are honestly not that many x values. But do you kind of see how that works? Yeah. So that's a harder question. There's actually one that's way harder that I know I have to skip.
The j.
No, that's the same thing, because you do the same thing. All right. So actually, that first page isn't terrible. There was one in here that was bad. Oh, this was bad. Yeah, you can skip 24. Yeah, you can definitely skip 24 on that one. That one's hideous. I'm not going to make you do that one. All right. All right, but, so there's two ways that, there's actually three ways you can be given information about how to take a derivative, information about how to take a derivative. One way is they can just say, here's the function, yay, right? You get a nice little polynomial, you get some trig functions, and I say, you know, what's f prime of whatever? You go, well, fine, I can take the derivative and plug a value, right? You're going to have to use chain rule. That's one way. Another way they can give you information is they can give you information in a chart like we did, where they said, okay, here's f, here's g, here's f prime, and here's g prime for a bunch of values. Compute some stuff, which is what we did, right? And the third way they give you information is, okay, right, we were nice, we gave you values. What do you do if I give you a graph, right? So here's our graph. And I'm going to ask the same questions. Like, for this, and I've already kind of done this. Like, you know, here's a graph of f, what's f of 2, what's f prime of negative 4? Well, f of 2 is, what's the y value at 2? You know, so here's 2, my y value at 2 is 3, so that's not hard. This says, what's f prime of negative 4? Well, this says, what's my slope at negative 4? So if I go, here's negative 4, what's my slope here? Well, if I count, okay, my slope is negative 2. Are we okay with that part? Right? So if it's f or it's g, right? You know, if I talk about f of 2 or f prime of whatever, or I talk about g of 2 or g prime of whatever, we can just look at the values, right? Okay, what happens if, so now what if I define, like I define h of x, it's the same thing here. I still define h of x as f of g of x. And I remember asking questions like this in pre-cal. You know, what's h of 2? Okay, well, what's g of 2? Well, let's see. G of 2 is here, and so it looks to be a negative 4. And then f of negative 4, I've already computed. F of negative 4 is up here, so that's going to give me a 3. Okay. This is composition of function. This is algebra 2, maybe pre-cal. I don't know if I would have asked this in an algebra 2 class, but I definitely would have asked it in a pre-cal class. All right? And again, you know, what's j of 2? But the interesting questions are down here.
Wait, how do you find J of two?
So j is defined, j of x is defined as g of f of x.
Oh, okay.
So it's a composition. It's the h and j are, even though we have different values, it's the same.
Okay.
We have different
Oh, I
functions.
see
Yeah.
underneath the graph.
Okay. All right. So now, what if I wanted to compute? So one question is actually going to be pretty easy, I think. Oh, no, it's not. Okay, so what if I wanted h prime of negative 3? That's the question 19. All right, but I need the graph to answer it. So I screwed it. What if I wanted h prime of negative 3? How do I do that? Well, let's see. Well, h prime of x, let's see, that's f prime of g of x times g prime of x. We're doing our chain rule thing. And I want to know what h prime of negative 3 is, so this gets to be a negative 3, and this gets to be a negative 3. And now we look at our information. So let's see, what's g prime of negative 3? Well, here's the graph of g. If I'm at negative 3, 1, 2, 3, I'm here. G prime is the slope here. And that slope is 1/2. And now to compute this thing, I need to compute what g of 3 is, or g of negative 3. So g of negative 3 is negative 4. So now I need to compute f prime of negative 4. And what's f prime of negative 4? That's here. So f prime of negative 4 is negative 2. So I get negative 2 times 1/2. And that's going to give me a negative 1. And the whole purpose of this page, front and back, is like you're finding an equation of a tangent line, it's the same thing. 24 skip, this was ugly. I have the answer key, but with how to actually solve it, but don't worry about that one. That one's actually very ugly. The rest of this isn't so bad. So, did this make any sense today? Let me pause this. I don't know if I...